Heavy lift drones require special motors for proper flight. With air taxis taking the world by storm, we will dive deep to understand how these motors operate. In addition, we will also look at what would happen to all motors if aliens attacked us. Stick to the end to find out. Heavy lift drones were first implemented in agriculture, but their most iconic use was in the US Army, where drones with abilities to carry up to 200 kilograms were developed by 2017. To understand heavy lift motors, we need to take a look at what makes them up. These motors, just like the others, have a rotor and stator. The rotor contains the permanent magnets, while the stator contains the coils and Hall sensors. The other major parts are the ball bearings for smooth rotation. When current is sent into the coils, it causes alternating poles at the end of each coil. Due to repulsion and attraction, the magnets on the rotor rotate. The current on the coils is varied to make the poles on the stator to rotate. This allows continuous rotation on the motor. Let me turn your attention to a small problem that brushless motors face that guided the design of heavy lift motors. The current in the stator coils is controlled by a component called an electronic speed controller. But controlling the motor is not a piece of cake. Let's take an example of this motor. If the user wants the motor to turn clockwise, the ESC, which is the electronic speed controller, decides to turn point 1 into a north pole and the others as alternating poles. Then the motor can move in the clockwise direction. Now, if the motor is to rest at this state, turning the same point 1 into a north pole at the start will only cause anti-clockwise rotation. This means that the rotation of the motor is mainly determined by the position of the permanent magnets attached to the rotor. How did designers then solve that problem? They used what is termed a blind start. For example, always turning part X into a north pole, which causes rotation that depends on the position of the permanent magnets. That rotation then causes eddy currents, which are read to understand the direction of rotation. Once the direction of rotation is understood, if it's the right direction, the ESC continues switching in the same way. But if it is in the wrong direction, the sequence is reversed and the motor stops before turning backwards to rotate in the right direction. The problem for heavy lift motors is that they have too much inertia, meaning a blind start will not be easy to reverse in no time without causing a surge in current to fight the inertia. This is why heavy lift motors have components called Hall effect sensors. These sensors read the magnetic field intensity of the permanent magnets close to them, and they tell the ESC the current position of the permanent magnets relative to the coils. This allows the ESC to know which switching sequence to follow. To achieve heavy lift, these motors run at low revolutions per minute. They technically have lower kV values, which kV values represent the revolutions per minute for every volt added. For example, a kV of 150 means that at 1 volt, the RPM is 150. At 2 volts, the RPM is 300. Heavy lift drones are made with larger radii to provide them with higher turning forces in order to drive their big propellers. Because of the high current required in the heavy motors, temperature monitoring and heat handling is very crucial. This is why heavy lift drones have proper aeration to allow for easy cooling. Research has gone into multi-stator motors, where one motor has up to 3 stators. As the applications of heavy lift drones extend each day, more types of motors and propellers are discovered to suit them. So, since we are nearly at the end, I need you to think about this for a second. If 2 alien ships set up a heavy magnetic field across the Earth, all motor-dependent objects will fall. Meaning, if it's a time of fully electric vehicles, planes, house robots, and more, you can picture the dependency. But further into it, what if that Earth being magnetically polarized is your home? That means, as more as we crave aeration for the heavy motors, we also need to look into magnetic shielding advancements in order to protect our motors from external magnetic field interference. What do you say about that? In the comment section.